I'm Abdul Raheem, a 9-pointer from IIT Bombay. In this video, we will be solving a previous year question from ordinary differential equations, and this is the end semester question paper of 2021. And from this question paper, I will be solving the 15th question. Okay, this was a question which is somewhat based on dimension theorem. Actually, I'm sure that it will help you from falling into some pits during the exam. So this is going to be interesting. So just get to know the question. The dimension of the solution space of the differential equation x cube d cube y divided by dx cube minus 7x square d square y by dx square plus 24x dy by dx minus 36y equal to 0 defined on minus 1 comma 1 is. So we have to find the dimension of the solution space of the given homogeneous differential equation. For that purpose, we actually have a dimension theorem, and from the dimension theorem, you might guess that the solution be just 3, because by the dimension theorem, according to suppose it satisfied some assumptions, then the dimension theorem says dimension equal to the order of the differential equation. So since this is a third order differential equation, you will naturally feel that the order should be, but may not be true, may be risky, may be costly. Anyway, let's try. Can we actually apply dimension theorem here? Just think about it. What were the assumptions that were made on dimension theorem? We needed the equation in standard form to be continuous on the interval that we are applying. Okay, so what's the interval we have? It is minus 1 comma 1. And just imagine this differential equation in the standard form. In the standard form means we will not have any coefficient for the third derivative. So we will have to eliminate that x cube somewhere. So I will divide the entire equation by x cube, and that will help me do that. But the issue is, will the coefficients be continuous in that range? In the interval minus 1 comma 1, will our coefficients be actually continuous? One coefficient will be minus 7 divided by x, because minus 7x square divided by x cube will be minus 7 by x. But at 0, it won't be continuous, because in the denominator 0 is coming. That will contradict with continuity. That's true, that you know already. So which means we can't actually blindly apply dimension theorem. But anyway, it might come out to be true. We don't know. But we can't actually blindly apply the dimension theorem. That's true. No, sure no. But we can apply dimension theorem for the intervals 0, 1 and minus 1, 0. That's true, because it don't contains that point 0 where the issue is happening. So we can actually find the solutions on an interval which does not contain 0, and which will actually help us to extend the solution to 0, which we had already done in an earlier quiz question. Okay, so we will be doing some similar approach in this question also. So we have the equation to be given as x cube d cube y divided by dx cube minus 7x square d square y divided by dx square plus 24x dy by dx minus 36 equal to 0. So on intervals not containing 0, this is just a Cauchy-Euler equation, because on every derivative we have the same order x term being multiplied with it. In that sense, this is a Cauchy-Euler equation, and we know a standard substitution for that. That is simply y equal to x raised to m. This will provide an auxiliary equation which we will solve and get the basis for the kernel of this differential equation. Okay, so we can do that. Let's just substitute x raised to m in this differential equation. So I will get the auxiliary equation to be from the d cube y by dx cube. From the third derivative, I will have m into m minus 1 into m minus 2, since I will be differentiating x raised to m thrice. And from the next term, we will have a minus 7m. And since I am differentiating twice, I will have m and m minus 1 plus 24 into differentiating once. So simply m and minus 36 equal to 0. Since we don't have any derivatives there, we will simply get a constant minus 36. Okay, I can simplify this. Okay, m into m minus 1 into m minus 2. M minus 1 into m minus 2 will be m square minus 3m plus 2, which on multiplying by m will get converted into m cube minus 3m square plus 2m. Okay, now simplifying this term, minus 7m into m minus 1, that will be minus 7m square plus 7m, and we have plus 24m minus 36 equal to 0. That is m cube minus 3m square minus 7m square. That means minus 10m square, m square. Then plus 2m plus 7m, that is 9m plus 24m. So it get converted to 33m, and we have m minus 36 as a single constant, which is equal to 0. Okay, so this is our auxiliary equation and we have to solve this cubic equation. Now, what is the procedure to solve a cubic equation? We have to find one solution by trial and error method. Then using that, we can factorize this equation. How? We will divide this cubic equation by m minus a, assuming that a is the solution which we found out by trial and error method. Okay, now after dividing, we will get a quotient and we will factorize that quotient, which will be a order 2 polynomial. We can do and we will find the entire solutions. So here you have to do that yourself. Apply the trial and error method. You will probably apply 0, 1, minus 1, 2, 3, etc. And from that you can find actually that m equal to 3 will be a solution for the given polynomial equation. So one factor will be m minus 3. And if you divide this cubic equation by m minus 3, you will get a quadratic equation whose factors will be minus 3 and m minus 4. So we will have m minus 3 whole square and m minus 4 as a perfect fraction for this equation. This you have to obtain using trial and error initially and later some computations which are like high school level, and I won't be doing that completely here. Okay, so that's it. So got the auxiliary equation solutions, that is 3, 3 and 4. 3 is coming twice and we have a 4. That means our basis for the solution set will be x cubed from 3. But since it's repeated, we will multiply by log x. So we will have x cubed log x, and from 4 we have an x raised to 4. These are the possible solutions. On which interval? On interval 0, 1 and on interval minus 1, comma 0 without including 0. Okay. So we have the solution y to be what? A linear combination of these elements. Ax cubed plus bx cubed log x plus cx raised to 4. This is true on the interval 1 to 0 with open 0. Okay, 0 is not included. Similarly, the same solution will work on the negative side also, but not on the point 0. Okay, so except the point 0 on the negative range, I use the same basis. That means I will use some new variables dx cube plus ex cube log x plus fx raised to 4. Okay, so this is the general solution, but now we haven't defined this function on 0. So some way we have to extend this solution to 0 and get a solution for the entire space, that is minus 1 to 1. That's our entire interval. And then find the dimension, that is how much degrees of freedom are left after extending and checking everything. Okay, now before that, let me just tell you one thing. Here actually we put log x because usually we consider only positive plane and we simply put log x. But actually it will be a log mod x if we consider negative region also. Okay, so in this equation we will have log mod x, but there is no need of putting modulus on each side. So I will simply put x in the positive region, but I will put a minus x in the negative region. Okay, so that came from the conditions of log. Log is not defined for negative numbers, so definitely I have to replace that x when x is negative by minus x, so that the terms become positive and log become defined there. Okay, now let's get into the game. What are the conditions this y should satisfy? Definitely this y is a solution of a third order differential equation, which means this y should be thrice differentiable. That's sure. Okay, let's check. Will this be differentiable thrice? Let's try. Okay, suppose I'm extending to 0 by this function itself by putting some value. Okay, whatever value I don't care now, but let me try to extend. So while differentiating x cube, x raised to 4, these are very cool terms. These are differentiable on entire real numbers, so they don't make any issues. But the middle terms you just consider, x cube log x, will that be actually differentiable? If you differentiate it, suppose it is differentiable, it will have x cube into 1 by x plus log x into 3x square. But that's some issues, because again we can't actually put some symbol values for the log x. We have to x and log is not defined at 0. So we will actually replace, we will try to replace by some value so that this doesn't have any issue. But the problem is log x has a infinite discontinuity. That if the continuity was something like a point discontinuity, we were able to fix it. But this is an infinite continuity, infinite discontinuity actually, because log x will be going to infinity from positive side, from the negative side also it will be going to infinity. Since both are booming to infinity, we can't replace them. We can't actually put something, do some finer adjustments in order to extend it to 0. That's not possible. So what we will have to do, we will have to make these coefficients b and e to be 0. Otherwise this log x is going to cause many issues at the point 0 because log is not defined, it's not continuous, many issues. Okay, so that b and e should be 0, otherwise that log x will be a big mess. So I have to remove those things. Now, are there any more conditions? If this is thrice differentiable, okay, since I have put b and e to be 0, I don't have to consider these two terms. Now this has to be thrice differentiable. This is a polynomial I can x very nicely, so I can even now start putting equal to here. But are there any further conditions for the derivative to be equal? The third derivative from the upper side will be, first derivative will be 3x square, second derivative will be 6ax, and third derivative from this side will be 6a, and the third derivative from this side will be 6d. Okay, we have a term containing this x raised to 4, but this will have an x term, and at 0 that will be simply 0, so that's not going to affect us. So actually we need this 6a and 6d to coincide, or they should be equal to 6d, because the derivative has to be continuous at the point 0 while extending. Okay, so for that we need 6a to be 6d, which means a should be equal to d. So now what are the different conditions we applied? One is that continuity of log x or differentiability of log x, whatever you can say, and also we need that thrice differentiability on the polynomial terms so that a and d should be equal. So now what is the actual look of our solution for this equation? That is ax cube plus cx raised to 4 on 0 to 1 interval. We can include 0 also. Okay, here we have not d, simply a itself, because they are the same. So we have ax cube plus dx raised to 4 instead of f. I simply wrote d. Okay, it doesn't matter what you may put. Okay, on the interval -1 to 0, 0 can be included. Okay, so now how many degrees of freedom do we actually have in this solution? We have an a, we have a c, and we have a d. So actual dimension is just 3, and you can even try to get a basis from this, which is not necessary from the degrees of freedom. It's clear that the dimension should be 3. You can try to get 3 linearly independent solutions from this by putting different values of a, c, and d, and prove that they are actually linearly independent. But that's not necessary. From the solutions form we can actually get that dimension is actually 3 itself. So the answer would be 3. But you assume, suppose you had done directly, blindly applied the dimension theorem, still you would have got 3 itself, right? So that means even if you had blindly applied, in this case, you might have been escaped and you will get the right answer. But in general, it's not true. The examiner can easily set a question in which if you blindly apply the dimension theorem, your marks will get cancelled. Okay, so such a question we had already solved in the second order case in an earlier quiz question. You can go back to that question to get a clear cut idea. Okay, I hope that this question will help you somewhere in the examination from falling into the pit of blindly applying dimension theorem. So thank you for watching the video. I hope that you enjoyed the video. Stay tuned to the channel. We'll be solving the remaining questions in the upcoming videos. Do join our Instagram handle and Telegram account in order to get live updates. Bye.